everyone, it's lovely to have you all here. My name is Iona Finney and I'm based in England. I'm a physical sciences reviewer at USTEM Matters and also one of the organisers for this research conference. I'm really looking forward to hearing the next talks, having seen our next speaker's project in the Expo area. Our next speaker is showing that young people can make a real difference through STEM. Now, I'm pleased to introduce Mahashri Ranjit Kumar. Mahashri is a high school student from India. She's currently researching different STEM solutions to mitigate climate change by studying weather patterns and their effects on renewable energy. Her current project revolves around the unseen side of solar panels, about which she's written an article for the Wire Science. She's previously also been a panelist at the United Nations COP26. Mahashri will be talking to us today about the afterlife of solar panels and how their disposal can have a negative impact on the environment. I'm looking forward to hearing more about her project. Welcome to the stage, Mahashri.
Hello, thank you so much for having me. I'm Mahashri Ranjit Kumar and I'm a high school sophomore from India. First and foremost, thank you to Youth STEM 2030 for inviting me and for also putting forth such a mega conference. And thank you guys for showing up because you are about to learn something very revolutionary if you have not already heard about it. And as you can see, I'm going to be talking about the afterlife of solar panels. So I feel like it's something that's seldom talked about. And I just want to shed some light on it and probably spread more awareness about it because it's a very, very important issue that is currently going on. So we all know solar panels are super cool, right? I mean, it gets the sunlight from the sun, it converts it into electricity, it powers our households, our schools, businesses, offices, whatever you call it, you name it. It powers everything, right? I mean, and it even cuts down our reliance on non-renewable energy sources such as fossil fuels. Isn't that all we need? I mean, it's even grown to become the world's cheapest form of electricity for companies to build, according to an organization called the International Energy Agency. And furthermore, it is the fastest growing source of electricity in recent years. That is mega. I mean, isn't that everything we need? So, what possibly could go wrong here? Solar installations have increased by more than 30% annually on average, and the cost reductions have been more than 90%. And I mean, everything's cool, but by 2050, the International Renewable Energy Agency projects that up to 78 million metric tons of solar panels would have reached their end of their life. So that would create an around 6 million metric tons of solar e-waste annually. That's huge, right? I mean, that's so much. Well, compared to the fills that are already filling the landfills, that's more than a lot because 6 million metric tons is not a small number. So, before we get into the details of the issue, I would like to give you guys a little background about what solar panels are and what it is made up of. So, there are three main types, which is the monocrystalline, polycrystalline, and thin film. So, solar panels are further classified into solar cells. So, you might have heard of this as the photovoltaic or PV cells, and these are further classified into semiconductors, and for now we can call them the P type and the N type. So, the P type stands for the positive silicon layer and the N type for the negative silicon layer. You can remember this as PNP and NNN. This is a component of a solar panel. It's as simple as it may seem. So on top, there's the frame. Beneath that is the glass, the solar cells, the backsheet, and the junction box. Even though these are like almost fancy names, it's a very simple model, but it has put in a lot of brains into it, honestly. So EVA, you may ask, stands for ethylene vinyl acetate, and it's a sheet of copolymer resin, and it's for the encapsulation of the solar cells. So as I mentioned before, the solar cell is what makes up the solar panel. So it is the most fundamental unit or the fundamental material of a solar panel. So to emphasize a little more on the types of semiconductors, there are two main, as I already mentioned, the P-type and the N-type. So you may ask, well, what are these letters? What do you mean? So the N-type, it has additional electrons that freely move around, as you can see in the diagram. And the P-type has electrons that have vacancies, which are known as holes. So when these layers are brought together, they almost overlap. And this forms the N-type to the P-type junction. The electrons move from the N-type to the P-type. And this almost forms a unique junction, and this generates electron potential in the material. So as you can see in the diagram, like I said, when sunlight strikes the surface of the solar panel, the connection, it knocks the electron loose and it leaves a hole behind. So the free electrons, it begins to congregate near the poles, and as more electrons come in, it fills the newly formed holes. So this entire process is how we get our electricity. It may seem like a handful, actually is, but it's a very interesting process. So, I mean, all of this is cool, but what happens to solar panels after their tenure of working? Well, they have a life expectancy of efficient working of around 20 to 30 years. That's about a few decades. But what about after that? You may have guessed it. It goes straight to the landfills, the dump yard. Well, you would probably ask yourself, come on, Mahashri, like, come on. Isn't that what happens to trash? What happens to everything after it's efficient working, after it's done working? Well, that is right, but it's also wrong because solar panels are not like every other material. They're made up of chemicals and different materials that I had already mentioned, such as glass, aluminum, silicon, and so much more. So when this reaches the landfills, there are heavy metals such as lead and cadmium, which seeps out of the cells. And many studies have proven out that it has immense result on our environment because this enters groundwater. It harms the plants, alters soil fertility, and affects our livelihood. So these metals have also been linked to health problems in humans. And as you can see in the pictures, once the solar panels have stopped working, they're just disposed. They're just thrown out to into the land, and that's when it affects our livelihood because not only does it take so much space up, but it also induces chemicals into the soil and indirectly affects us. But it also directly, even though we know it directly does also affect us. So this issue is also linked with SDG 7, affordable and clean energy, SDG 13, climate action, SDG 14, life below water, and SDG 15, life on land. So I would like to take a short break here and tell you guys that when I was researching about this topic, I honestly beforehand I was keen to make a change, but I did not know where to start. So my piece of suggestion would be to start researching because we have a tool that our past generations have not been given, but for us it's more of a blessing than a curse. We must use it in that way, and I think that biggest tool is the internet. It has helped me a lot personally because not only when I've realized such a major problem is taking place, I decided to write an article about it because this problem is very understated. It's barely talked about, and I didn't really like the way it was showcased in public light. So I decided to write an article to the Wire Science, and that's when I thought to myself that if I can do this, all of you can do this. And as young people collectively, it has become our duty to start researching and to start spreading awareness about even meager issues because eventually these will turn out into bigger problems and it will affect us in the future. So yes, coming back to the topic, solar panels, after they reach the dump yard, you may ask, like, what happens? Does it only leach? Does the chemicals only leach out? Is there no way to stop it? Well, scientifically, solar panels can be recyclable. That's true. Thanks to STEM, we have found out efficient ways to recycle solar panels. It can be separated into its components of lead, copper, gallium, cadmium, aluminum, and silicon, and it can be recovered and reused in new products. So, all in all, can solar panels be recycled? The short answer is yes. Silicon solar modules can be split up into its basic materials of glass, plastic, aluminum, and so these are three basic materials that can be recycled in mass quantities. As far as this may seem cool, I mean, we have a problem, we have a solution, but where are we getting stuck, you may ask? And this is where it comes down to us because even though all these processes exist and it's doable, it has not been taken place efficiently throughout the world yet. Though there are a few countries in the European region working towards this, it has not been beneficial all in all because solar panels are not only existing in a specific country or a specific place, it's throughout the world. The world is changing. We have turned towards renewable energy sources, and that is solar panels. So it's important that we all work together collectively to reduce its impact on the environment after its tenure of working. So By we, I mean not just big governments or big companies and the world governments. I mean us young people as well. It's important that we know such an issue exists because it's an understated issue, and it's important that we also spread the word about it compared to how it is right now, because not much is being talked about it. And so it's really on us on how we portray this issue. So, like I had mentioned before, this problem is directly related to the SDG 7, 13, 14, and 15. So, that's a lot. And this one simple problem, if it can relate to 4 SDGs, I believe there's so many more problems which can relate to so many more SDGs, and it's up to us to find out what it is. So, all in all, solar panels have its own share of boon and bane, and it's up to us to make sure that it's more of a merit and a credit to the society than a drawback, because the way we maintain it, the way we look after it does matter. So I hope you guys do understand now that solar panels are more than just, those really cool renewable energy sources. They also have a dark side, and I don't think it will be as dark as it is if we all look into it. So thank you so much for having me today, and thank you.
Thank you, Mahashri. Please share your appreciation for Mahashri in the chat. It was really interesting to learn about the impacts of disposing solar panels and how it relates to the SDGs. Thanks so much for being part of the conference today, Mahashri.